Guys, we are going over the Friday problem here today, the Schoology question here, the 2021. This is the one that's supposed to look like the 25-minute problem. We don't know if it's going to be perfect or not. We'll get more information on that on April 28th, but we're going to try to work through it. A little bit trickier than the other ones, but we'll see how we do with it. All right, so that's what we're going to work through. I'm getting some results from students. We're doing pretty well. Part E is pretty tough, but when you look at it here in a minute, you'll be like, oh, okay, I could do that. But at first glance, it looks a bit tough. All right, we're going to work through this together. I'll just kind of show you the scoring system. I gave you the scoring on the rubric, but this is going to be a little more detailed. So we'll see how this goes. All right, here we go. So part one, it says the graph is given above. It's on the interval from -1 to 11. The area is bounded by f of x. So from -1 to 2, this guy is 4. From 2 to 6, that area is 3, and obviously it's below the x-axis, so it's going to be negative. And that right there is 2. It does not tell me anything about 11 from 10 to 11, but it doesn't apparently like it's going to matter. Okay. They also told me h of x. All right, so don't forget about h of x up here either. And everyone's favorite, they also told me g of x is right there. All right, so a bunch of different stuff going on. Obviously, we're using all these different parts to answer these questions. Okay, let's look at part A. Part A says show that h of x is continuous. Remember continuity. Okay, there are 3 things you got to show for continuity. You need to show the limit as h approaches -1 from the left. No, not h, sorry. X approaches -1 from the left of h of x is going to be equal to the limit as x, or actually, let's do this one. Let's go h of x in the middle, or h of -1, sorry, is going to be equal to the limit as x approaches -1 from the right of h of x. Write stuff out. The limit from the left, the middle, and the right are all equal to each other. Okay, so far our biggest mistake has not been showing this kind of stuff, limit notation. Okay, you're doing everything right, but without that, it's not going to get you points. All right, we're trying to do that. So if we're looking at this graph, limit as h approaches -1 from the left, would that be that equation? So x squared plus 3x minus 2. That's going to be pretty easy. I'm just going to plug in -1. So 1 minus 3 minus 2, I get -4. So the good news is everything's going to be -4. I've got one of them. Now I just need to find all of them. All right. Then I need to see, is that equal to h of -1? Well, to find h of -1, I'm going to use this equation because it's underlined. And both of these are the same. All right. So I'm going to just kind of cheat here and say this needs to be equal to this thing. So we're going to find it. Okay. So I'm doing g of x. This is g of x. It is the area under the curve starting from 2 and going to x. So we are going to integrate from 2 to -1 of f of x dx. Okay, so I'm going to find the area under the curve starting at 2 and going to -1. So I'm going to flip that, and I'm going to say I really want to know the area from -1 to 2 because I don't like the lower bound on bottom. I want the lower bound on bottom, sorry. And so if I go from 2, oh, that's -4. This is equal to this. And so I'm going to just kind of put that together. I'm going to say because the limit as x approaches -1 from the left of h is equal to the limit, I'm running out of space here, as x approaches -1 from the right is equal to f of -1. I'm sorry, h of -1 is equal to -4. H is continuous at -1. Boom. All right, a little bit ugly there, and I know I didn't give you a ton of space there, but that's the main idea. All right, we found this limit, we found this limit, and that's equal to the value. We showed both of them were -4. Limit from the left, limit from the right, and the value all have to be equal in order to show continuity. Okay, basically, scoring-wise, this would have been 1 point. I'm guessing this would be 1 point, and then doing this at the end, that all of these things are all equal to -4 would be the third point. Probably we could have just written that top line at the end and then said, because this is true, we're continuous as well. But we needed to show our work definitely for this and this. All right. So there's 3 points on part A. Let's look at part B. Order the values of H double prime from smallest to largest. Explain your reasoning. So basically on this, we just need to show the numbers. Okay, this would have definitely been a multiple choice question before, but now we don't get multiple choice questions this year. So let's do this. I'm going to just kind of explain what's going on. I'm just going to go step by step. I haven't even looked at this problem yet. We're just doing it right now. Okay, H double prime of -2. All right, so -2, if I'm doing -2, I'm jumping into this world because if H is less than -1, it's this one. All right, so I'm going to take the second derivative here. It's written right here for me to look at as well. So H prime of X would be 2X plus 3. H double prime of X would just be 2. So H double prime of -2 would be 2. I just wrote it out, boom, got a number. That would probably be 1 point to there. Okay, that's an easy point. Then we're going to find H double prime at 2. So if I'm finding H double prime at 2, I'm landing in this world. I'm looking for the second derivative. All right, so this is G. It looks like this. If I wanted to take the first derivative, if I want to find G prime, then it would just be F. Okay? If I want to find the second derivative here, okay, if I'm looking at the second derivative on this one, then it would look like this. It would be G double prime at 2. Okay? Or in other words, I'm looking at the slope of this graph at 2. Okay? Because F, we took one derivative, it got rid of the integral. We take the second derivative, it's the same thing as F prime at 2. Okay? Well, let's look at F prime at 2. What's going to be true about the slope right here at this graph? Oh, it's negative slope. Okay? So F prime at 2, it's negative. I'm just going to write negative right below it. But I went from here to this idea to this idea to that idea. I just kind of worked my way down that line. That would be my explanation. Hey, we wanted H double prime at 2. Oh, because of that, we would be landing in this category. So we'd be looking at G. I want to find the second derivative. Well, G prime would just be F. And if I wanted G double prime, that would be F prime. And so basically, we just took the derivative twice of that function. All right, cool. So that's negative. I want to find H double prime at 10. So same thing's going to apply here. All right. If I want to find H double prime at 10, that is the same thing as finding G double prime at 10, which is the same thing as finding F prime at 10, which means I'm looking at this graph at the slope at 10. What's the slope at 10? It's 0 because it's a minimum. Okay, so this is F double prime at 10. That is 0. So if I were to put these things in order, I would say it goes biggest, we're going from smallest to largest. So the smallest one is going to be H double prime at 2 because it's negative. And that answer right there is going to be less than. My next one would be 0. So H double prime at 10, which is going to be less than H double prime at -2. We're guessing a little bit here on scoring, but I would guess 1, 2, 3. Hopefully you can put that together at the end and not need an extra bonus point. I'm not exactly how sure they would score that, but that's the right idea. 3 points on B. Let's go to part C. This is the one that so far we have just not done well at. You are finding the limit. You see the limit of a fraction in your brain right now. You see limit of a fraction, you should be thinking L'Hopital is a pretty good chance here. If you see a fraction, you're thinking L'Hopital, it's probably going to happen. In order for you to do L'Hopital, I'm going to say this for the 47th time, okay? In order to do L'Hopital, you need to find the limit as x approaches 6 of the top of this problem, and you need to write out all of this stuff. And then you need to write the limit as x approaches 6 of the bottom. If you do not write this, you cannot get full credit. You have to do that. So when I'm going to find the limit of these things. All right, so if I find the limit of the top, and I'm doing G at 6. So if I plugged in 6 here. So I went from 2 to 6 of f of t. Oh, 2 to 6, it's going to be 3, but it's below the x-axis, so that's negative 3. Sorry, I'm trying to go back and forth. All right, so this is negative 3 plus 3e. It's going to be 12 minus 12 up there, so that's 1. Oh, okay, this is 0. I plug in 6 here. Okay, 6 squared is 36 minus 36 is going to be 0. Since it's 0 over 0, that's going to be 0, that's going to be 0. I'm going to write by L'Hopital. And I'm going to go ahead and write out L'Hopital's rule. Okay, we're going to find the derivative. By L'Hopital, we really are finding the limit. Make sure you're writing limit notation as x approaches 6 of g prime of x. Plus, I'm taking the derivative of e. The derivative of e is what you see times the derivative of the exponent. So I'm going to multiply by negative 2 here. All right, to make this problem a little bit less ugly, I'm going to make this a negative 6 in front, but you get the right idea. I'm going to take the derivative of the bottom. The derivative of the bottom, x squared minus 36. Oh, that derivative of that is 2x. Cool. I'm still finding the limit as x approaches 6. So I'm going to plug 6 in. So I'm finding g prime at 6. Well, okay, I'm taking the derivative of this. So what am I doing if I take the derivative of 6? I'm taking the derivative of this integral. It's just f. So f at 6 is 0. Okay, so I'm just going to write that in. So I'm finding the limit as x approaches 6. This is 0. Actually, I don't need to write the limit notation because I'm actually doing the limit now. Sorry. 0 minus 6 times e to the 0 power all over 2 times 6. That is negative 6 over 12. It gets me negative 1/2. Boom, there's my answer. Let's show you points. This right here, this is equal to 0, and this is equal to 0. That is 1 point. And if you don't get that point, you can get 0 other points on this problem. If you don't write the limit separately, you'll get no other points for this problem. Okay, I'm trying to emphasize that. I felt like I have, but apparently not well enough. That's 1 point. That's a second point by saying by L'Hopital. And the third point is going ahead and getting that answer of negative 1/2 in the end. Okay, 1, 2, 3. Let's look at part D. Part D, definitely we're starting to get into some difficult land here. Okay, let's look at this. We are taking the integral of that thing. I'm integrating this, and the thing that I'm going to look at as I integrate this, 2 different ideas. All right, and we could get a little bit fancier here if you wanted to and do some different things. This right here is going to be a key for me. All right, I am taking the integral of this thing, and I've got a parenthesis. All right, so when I look at that problem right there, I'm thinking, hey, I'm integrating something inside of a function inside of parentheses. This is a u sub problem. My u is going to be 2x minus 4. And then I'm going to find du over dx. Okay, du over dx. I'm really looking at just this idea right here. This 5 right here, that's easy. Okay, we'll mess with that in a second, but let's just do this first part. Okay, du over dx. Well, what's my du? Well, 2. So it's going to be du over 2 is equal to dx. I changed my bounds. Okay, I changed my u, so I'm going to change my bounds. My upper bound is now going to be, hey, I plug 1 into this. So if I plug in, no, that's a lower bound, just kidding. I'm going to plug 7 in for my upper bound, 14. Upper bound is 10. Lower bound is negative 2. So let's set that up. I'm integrating from negative 2 to 10, 3 h prime of u. I'm going to go ahead and pull that 3 out in front because it's just a 3, times du over 2. All right. Let's take a break real quick and let's look at this guy. This 5 right there. It's plus 5. Think about what that plus 5 is doing. It is taking your graph and shifting it up. We could have separated this thing into another integral that is just from 1 to 7, 5 dx. Remember, if we're integrating two things that are being added, it's just like, hey, I could do this one and then that one. Well, understand what that second picture is going to look like. It's a line at 1, 2, 3, 4, 5. It's a straight line. We're finding the area of the curve starting at 1 and going to 7. And so, hey, it's 6 across. It's 5 tall. Oh, this answer right here is just 30. You could have integrated it, but I just like doing it that way. Okay, so 30. That's what this guy is. Plus, I'm going to pull out that 3/2. I got that 2 right there. I pulled it out in front. I'm integrating from -2 to 10, h prime u du. So what is the antiderivative of h prime? Well, the antiderivative of h prime is h. I'm going to integrate that thing. So that is h of u, and I'm evaluating that thing from -2 to 10. All right, that's what we're trying to do here. So I've got 30 plus 3/2 times, I'm going to plug in the upper bound, I'm going to plug in the lower bound. So h of 10 minus h of -2, upper bound minus lower bound. Then we're actually going to do that. So it's 30 plus 3/2. I need to find out what h of 10 is. So let's go back to the top here. Okay, h of 10. Well, if I'm doing h of 10, I'm plugging into this equation. I'm finding h of 10. That means I'm using this equation. I'm starting at 2, and I'm integrating all the way to 10. So that means I'm finding the area under the curve. So this is 3. That's 2. So it's -3 plus 2. This is -1 minus h at -2. All right. So if I go back up here, h at -2. All right. So I'm using this equation. I'm plugging in -2. So -2 squared plus 3 times -2 minus 2. That's 4 minus 6 minus 2 more. It looks like it's -4 minus -4. And that's my answer. I'm going to leave this right here. Boom. I'm going to put a box around it and get me my answer. If you were actually to do this, and you do get to at least use your calculator to simplify, I get 69/2 in the end. Is that a tough question? Yep. Are you great at U-sub? Probably not, but you could do it. Okay. If I'm looking at points here, okay, I would say point 1 is setting up a U-sub. Okay. Setting up some sort of U-sub with 2x minus 4 and you changed bounds. Point 2 would actually be getting this guy right here. I would say that line right there would be point 2, and then point 3 would be, and actually I would say that this guy right there is point 2. Now without the 30. And then point 3 is getting to this answer in the end. Okay, or even just what's in yellow. That one's a tough one. But again, that's how they're going to tell the difference between a 4 and a 5. Okay, so don't be too worried about that one. Part E, I've not seen anybody get this one right yet. We've got people close, but it's a little bit different. All right, so let y equals kx be the particular solution to this differential equation. Okay, so dy over dx equals h prime of x and y minus 1. The key to this problem, and a lot of students that have turned this in so far have not done this part, when x is less than -1. And so just looking at this, I hate it because I've got y, x, h. That's too many letters going on. All right, but what they said here is that h prime of x, and I'm doing less than -1. So let's go back up to the start here. I want to know h prime of x when x is less than -1. And so the good news is I can do a substitution. Oh, when x is less than -1, this is what h is. So what is h prime of x going to be when it's less than -1? Well, it's going to be 2x plus 3. I just took the derivative right there. And so instead of this ugliness that we had here, I'm going to write in 2x plus 3 right there. And then once you do that, I think the rest of this problem is not too bad at all. But that part right there is kind of the tricky step. All right, so once we've done that, then this is a particular solution to a differential equation. Sikio mode. We're going to separate first. So we're going to divide by y minus 1. we are going to multiply by dx. I separated. Now I'm going to integrate. So boom, boom. Y minus 1, that's going to be the natural log of y minus 1, absolute value signs, is going to be equal to integrate 2x, add 1 to my exponent, divide by my new exponent, add 1 to my exponent, divide by my new exponent, plus c. Then I'm going to find this thing at negative 2, 2. So I'm going to solve for c. So separated, then I integrated. Now I'm solving for c. So I'm going to plug in 2, 2, negative 2, 2. So it is natural log of 1 over here, because 2 minus 1. And then I'm plugging in negative 2 there. So that's going to be 4 minus 6 plus c. Natural log of 1 is 0 equals negative 2 plus c. So c is 2. 1 point if you separated correctly, that's not separating. 1 point if you separated correctly, 1 point if you integrated, 1 point if you solved for c, and then your fourth and final point is going to be solving for y. So let's do that. So we're taking this 2, we're plugging it back in right there. The natural log of y minus 1 is equal to x squared plus 3x plus c. No, not plus c anymore. Let's go plus 2. Okay? Then we're solving. To get rid of natural log, I'm taking the e of both sides. That's going to cancel. So absolute value of y minus 1 is equal to e x squared plus 3x plus 2. Cool. A reminder that if we've got this e and we've got that 2 right up there, and it's being added, you could multiply by that if you'd like. You don't have to. But now I'm going to rewrite this as y minus 1. I'm going to pull that 2 out in front. Don't have to do that. I just like doing it because it's less stuff up in the numerator. This is absolute value. So to get rid of the absolute value, I'm going plus or minus. And then to get rid of the 1, I'm going to add that over as well. So 1 plus or minus 2e to the x squared plus 3x. All I need to do now is the options. Decide, is it positive or negative? And so if I plug in negative 2, that would get me 4. That would get me e to the negative 2. Sorry. I plug in negative 2. Boom. What do I want, positive or negative here? I definitely want positive here. Okay, I want that to be 2 in the end. I did something funky there with my exponent, but I think we're good. All right. 1 point for this, 1 point for that, 1 point for that. So 1, 2, 3, 4. Hope that makes sense to you. If not, let's keep working on it and see what other questions that we have here and make sure we can understand what's going on. Okay. I don't like bringing this 2 down. I think that's what's throwing me off more than anything else. I think if I leave that plus 2 up there, this becomes a lot easier problem. So let's look at that real quick. Sorry, I got distracted by this and it was throwing me off. I'm going to leave that 2 up there just because then when I plug in, if I plug in negative 2 up here in the exponent, I get 0, and e to the 0 is going to be easier to mess with. So e to the 0 would be 1. 1 plus 1 is what I want, and that's going to get me 2. Okay. So that got me where I wanted. This is the right answer here. Sorry, my brain quit working on this early morning. Hope that makes sense to you. Lots of different points going on there. I think that's a pretty good question for the AP exam. It's tough, but that's why we're prepping for 4 weeks. All right, we have 4 weeks to get ready for this exam. That's what the kind of questions we need to be doing, and that's going to help us get a better understanding. Hope that helps. If not, ask me questions, and I will work through it with you. Have a good one.